Welcome to this explainer. Look, if you want to troubleshoot faster and truly master your network, you really have to look under the hood. If you work with Juniper Networks equipment, you already know these devices handle an immense amount of data effortlessly. Well, today, we're going to unpack the internal architecture and routing operations of Junos devices to understand exactly how the system makes that possible.
So here is a wild question to start us off. How does a router process millions of packets a second without its brain totally freezing up? Imagine a massive intersection where the traffic cop is literally trying to read a map, answer a radio, and pave the road all at the exact same time. In a lot of traditional systems, everything just gets bogged down. But in Junos, the answer lies in a brilliant architectural separation that we're going to explore right now.
All right, here's our roadmap for today. We're going to cover the two-brain architecture, inside the routing table, the forwarding table explained, traffic forwarding concepts, and finally, routing policies control flow.
Okay, jumping into part one, the two-brain architecture.
The foundational concept of a Juniper Networks device is that it operates using two distinct software processing components. It's kind of the secret sauce of Junos OS. Think of it like a thinker and a doer. You've got the routing engine, which acts as the planner, maintaining tables, controlling protocols, and handling all the monitoring. Then, totally separate, you have the packet forwarding engine, the doer. Its absolute only job is to physically execute packet forwarding and apply filters. Because protocol traffic goes straight to the thinker, the doer isn't constantly interrupted. It just keeps forwarding traffic.
What is absolutely brilliant here is the software modularity. The routing engine doesn't just run one giant, fragile program. It breaks tasks down into separate processes. You've got RPD for routing protocols, chassis D for the physical hardware, and snmpd for monitoring. This means if your snmp monitoring glitches out and crashes, no big deal. Your vital routing protocol process doesn't even blink. Your network just keeps running. Let's move on to part two, inside the routing table. So let's look at the routing engine's primary workspace where all that pathfinding actually happens. The RPD, or routing protocol process we just mentioned, is really the beating heart of Junos routing. It starts all your configured protocols, OSPF, ISIS, BGP, you name it, and builds a master collection of every route learned from your neighbors. If you're ever troubleshooting a missing route, this process is exactly what you'll be interacting with.
Now, protocols in Junos don't actually talk directly to each other very much. Instead, the RPD uses multiple routing tables as these central gathering points. You've got init.0 for IPv4 routes and inet 6.0 for IPv6. Think of these tables like a massive, incredibly detailed atlas of all possible roads across your entire network.
All right, part three, the forwarding table explained.
Having a giant atlas is great for planning a road trip, but you need something way faster for real-time driving, right? Here's the thing. Not all those learned routes are actually used. You might have 5 different ways to reach a destination network, but the routing engine is going to evaluate them and pick the absolute best path. That top pick becomes your active route.
And this distinction right here is huge for mastering Junos. The routing table up on the routing engine is that giant atlas holding all learned routes. But the forwarding table, that's your active turn-by-turn GPS. It holds only the active routes. And here's where the magic happens. The OS copies this optimized forwarding table directly down into the actual hardware of the packet forwarding engine.
So the workflow goes exactly like this. First, protocols learn from neighbors. Second, RPD dumps everything into the main routing tables. Third, the active routes are calculated. And finally, those active routes are pushed down into the forwarding table in the hardware. Because that active map lives right on the hardware, forwarding happens at line rate without ever having to ask the routing engine for directions.
Let's shift gears to part 4, traffic forwarding concepts.
Not all packets hitting a router are created equal. So what happens when a packet isn't just passing through, but is actually destined for the router itself? How does the device tell the difference between some random data payload and a critical routing protocol update meant specifically for it? Basically, Junos recognizes 3 distinct flows. First, the flow of routing information, which is handled strictly by the routing engine. Second, transit data packets, just data trying to get from A to B, handled exclusively and super fast by the packet forwarding engine. And third, local packets. These are packets sent to or from the router itself, like an ICMP ping or a telnet session. Those local packets get punted directly from the physical interfaces up to the routing engine.
Now, because those local packets are going straight into the thinker brain of the router, we've got to be extremely careful. The routing engine is critical infrastructure. To protect it, we use firewall filters specifically applied to local packets. This blocks excessive traffic and shuts down denial-of-service attacks before they can bog down the brain. Honestly, configuring those filters on your loopback interface is one of the most vital security tasks you'll do as a network engineer.
And finally, Part 5, Routing Policies Control Flow.
We've talked about how routes get into the table, but how do we actually act as gatekeepers for all that info? Well, we use import and export policies. Think of import policies as the inbound bouncers for your routing table. They dictate exactly which learned routes are actually allowed inside. Export policies, on the flip side, control what active routes we pull out of the table and advertise to our neighbors.
Okay, here is the golden rule, and this trips people up all the time when they first start with Junos. You always describe moving routes from the perspective of the routing table. Importing means moving a route from a protocol into the routing table. Exporting means taking an active route out of the routing table and giving it to a protocol to advertise. The routing table is literally the center of the universe for these policies.
I'm going to leave you with this thought to ponder on your networking journey. We know the brain and the brawn are strictly separated. The routing engine maintains the tables, and the packet forwarding engine just blindly forwards using its copied table. So, if the RPD process on the routing engine randomly crashes and has to restart, what happens to the actual data packets flying through the hardware at that exact second? Based on the brilliant two-brain architecture we just broke down, I'll let you figure that one out. Thanks for hanging out with me for this explainer.